So in this part 3 of solving equations, we're going to look at solving absolute value equations. So let's kind of review a couple of things from a previous course. Let's discuss absolute value of 3 versus absolute value of -3. Okay, so the absolute value of 3, if you recall, when you first talked about absolute value, the absolute value of x represents the distance that x is from 0 on the number line. So that's what the absolute value of x means. So the absolute value of x indicates the distance that a number is from 0 on the number line. So if we look at absolute value of 3 and we look at this in terms of a number line, and let's say this is 0, absolute value of 3 indicates what is the distance from 0 that the number 3 is. So 3 is here, so the absolute value of 3 measures this distance here. So the absolute value of 3 is 3. So if you look at the absolute value of -3, the same idea. So here's 0, here's -3, and so we're asking ourselves, what does the absolute value of 3 equal? So what is the absolute value of 3? So remember, just like the absolute value of the absolute value of -3, I guess I meant to say. Just like the absolute value of 3, that measures the distance that 3 is from 0. So the absolute value of -3 measures the distance that -3 is from 0, and that distance is also 3. So the absolute value of 3 is 3, and the absolute value of -3 is also 3, because 3 and -3 are both 3 units away from 0. Okay, so in terms of absolute value equations, so let's say we had, we want to solve, we're going to look at a simple one first. So let's say we want to solve the absolute value of x is equal to, let's say, 4. All right, so just in terms of distances, what that means is I'm looking for a number x, that is 4 units away from 0. So I'm looking for a number x that is 4 units away from 0. So 1, 2, 3, 4. So that's 4 units. And then I'm looking at 1, 2, 3, 4. So that's also 4 units. So the absolute value of x, so when I solve the absolute value of x equal 4, I'm asking myself the absolute value of what number is 4 units from 0. So the answer would be 4 and also -4. So those are two solutions. So 4 and -4. So in general, this is how you're going to solve an absolute value equation. Okay, let's suppose we have an expression u, and u could be something like x plus 4, x 2x minus 1, things like that. So some kind of expression here, an algebraic expression. It's not necessarily just x, but it's something that involves x. And let's say that that expression is equal to, let's say, c. And so when solving an absolute value equation, you want to rewrite it. You want to rewrite this absolute value equation without absolute value bars. Okay, and to do that, you're going to use the idea of distances. So just like we did a while ago, so the absolute value of x equal 4, so we're asking ourselves the absolute value of what number is 4 units from 0. So we said x equal 4, and x would equal -4. So the absolute value of this expression, I want to be c units from 0. So based on this, we could say u equals c, or u would have to equal a -c. All right, so that idea here. So x equal 4, or x equal -4. U equals c, or u equals -c. Okay, so let's look at this example. Okay, so let's look at this. This will be number 1. You want to solve each of these absolute value equations. So let's suppose we had the absolute value of x minus 3 is equal to 5. Okay, so x minus 3 is equal to 5. So according to our definition, according to this property, the absolute value of some expression equals c. I rewrite it without absolute value bars, and so notice it will be two equations, c and negative c. Two equations, 4, negative 4. Okay? So two equations, c, negative c. So you rewrite the left side without the absolute value bars. So this expression has to be c units from 0, and this expression has to also be c units from 0 as well. So c units to the right, c units to the left. Okay, so I want to know the absolute value of x minus 3 equal 5. So with that, what I'm asking is what value of x, what must the value of x be so that x minus 3 is 5 units from 0? Okay, so on the number line, 5 units from 0 would be to the right and to the left. So that's why you would say x minus 3 equal 5, or x minus 3 equals a negative 5. All right, so remember, you just rewrite this expression. So the common mistake people make is that they remember the absolute value of negative 3 is 3. That's true, okay? But notice that's just one term right here. The mistake people make is they want to rewrite this as x plus 3 because they see that negative 3 and they think that they have to take the absolute value of that negative 3. You got to be careful. That's not one. Negative 3 is not by itself. You have x minus 3, so you have this binomial. So all you got to do is just rewrite this expression. Don't do anything else. So all you're doing is rewriting this expression. Notice x minus 3, x minus 3. And all you're doing is using the fact that x minus 3 is 5 units to the right of 0, and x minus 3 is 5 units to the left of 0. So that's why you see negative 5 there. And then you solve these two linear equations. So plus 3, add 3 to both sides, combine like terms, x equal 8. And then over here, plus 3, and then x equal negative 2. Okay? And you don't you don't have, remember in the previous lesson you had to check for extraneous solutions? You don't do that here because I didn't raise both sides to even power. So both of them should work. So if you plug it back in, 8 minus 3 is 5. The absolute value of 5 is 5. And you substitute negative 2. Negative 2 and a negative 3 is a negative 5. Absolute value of a negative 5 is 5. So they both work. All right. Now, here's something I got to mention to you, though. If you have the absolute value of x equal negative 3, so if you have the absolute value of an expression and you have a negative number on the other side, that's not going to make sense. You got to understand why that's not going to make sense. Remember, the absolute value of x measures the distance that a number is from 0. Well, I'm indicating that this distance is negative 3. But distance can't be negative. Distance must be positive or 0. All right, so it can't be negative, never negative. So if you have that situation, right away, you would say no solution. All right, you would say no solution. Now, let's suppose you did make a mistake. Suppose you did make a mistake here. And I'm saying it's called a mistake, and you'll see what I mean. So let's suppose you did say, all right, so I'm gonna rewrite this as two equations. So x equal negative 3, x equal positive 3. Okay? And so right away you solve for x. But check it. Check this. Notice what happens. Okay, notice what happens when you plug 3 and negative 3 back into the original equation with the absolute value bars. So let's check x equal negative 3. I have the absolute value of negative 3, and the question is that equal to a negative 3? Well, the absolute value of negative 3 is 3, and 3 does not equal negative 3. So if you check x equal 3, the same thing applies. The absolute value of 3, you're asking, is that equal to negative 3? Because that's what the right side is. Well, the answer is no, because the absolute value of 3 is 3, and these two do not equal. Right, so that's why you would get no solution here. So the absolute value of an expression, if you have the absolute value of an expression that's equal to a number, a negative number, you automatically say no solution. Don't do the work. Because what's going to happen is if you do the work, you're going to say these are the solutions right here, and they're not because you didn't check. Because you really don't have to check if this is a positive number or 0. So if this is positive 0, you don't have to check this. Okay, now also remember, before you can break it apart right here, the absolute value bars have to be by itself. All right, so this has to be by itself. All right, so we're going to get one. We're going to do one in a little while where it's not by itself. So for example, let's suppose we had absolute value of 2x minus 1 plus 3 is equal to, let's say, 8. So the absolute value of 2x plus 1, 2x minus 1 rather, plus 3 equal 8. Now, remember, you have to get the absolute value bars by itself. So you got to have this first. It must look like this. The absolute value of u must equal c. So you got to get the absolute value expression, the absolute value bar expression first. So you got to subtract 3. That's the first thing you have to do. If you don't, you're going to get an error. So when I combine like terms, I'm going to get the absolute value of 2x minus 1 is equal to 5. And now, notice this is positive, so I'm going to get some solutions. I just need to split it up though. So 2x minus 1 is going to be 5 units to the right, and then 2x minus 1 is going to be 5 units to the left. And then you solve these linear equations. So you add 1 to both sides, combine like terms, you get 2x equals 6, and then to get x by itself, you divide both sides by 2, and so therefore x is 3. And you can check this mentally. Remember, always go back to the original, because you could have made a mistake somewhere along the way. 2 times 3 is 6. 6 minus 1 is 5. Absolute value of 5 is 5. 5 plus 3 is 8. And that's what you wanted. Okay, over here, add 1 to both sides. Combine like terms. I get 2x equal negative 4. All right, so if I divide both sides by 2, I get x to be negative 2. Okay, now check it. You don't have to because remember, when I got the absolute value bar by itself, this was 5. It was a positive number. But check it. 2 times negative 2 is a negative 4. Negative 4 and a negative 1 is a negative 5. Absolute value of negative 5 is 5. 5 plus 3 is 8. All right, so they both work. So your solutions are x equal negative 2, comma 3. Those are your solutions. X equal negative 2, comma 3. All right, so remember, you must get the absolute value before you can split it up. Before you can split it up, you must get the absolute value bars by themselves. And then once it's by itself, then you split it up. So this expression must equal 5 units to the right of 0, and this expression must equal 5 units to the left of 0. So hence positive 5, negative 5. All right, number 3. Suppose you had 2 times the absolute value of 3x minus 5 is, let's say, plus 1 is equal to 7. Let's make it 9. Let's do 9. Because if I did 7, I'd get 5 again, and I had 5 in both situations. Okay, so notice I got to get this by itself. Remember, you have to get this by itself. So you want this isolated. So I need to get rid of this 1. I need to get rid of this 2. So let's subtract the 1 first. So subtract 1 from both sides. Combine like terms. I get 2 times the absolute value of 3x minus 5 is equal to 8. All right. Now, if you make a mistake, you distribute a 2, since you notice this is positive, and you distribute a 2, you'd be fine. You would have the absolute value of 6x minus 10. Now, this rate negative 2, you need to be a little bit careful, depending on what this is. But because this is not really parentheses. It's still considered a grouping symbol. it does mean something, absolute value of this expression, which remember means the distance that number is from 0. But to be on the safe side, since I'm multiplying this by 2, just go ahead and divide by 2. So basically what's going to happen is this. So you divide both sides by 2, just like this. And so 2 divided by 2 is 1. And so I get the absolute value of 3x minus 5 equal, and then 8 divided by 2 is 4. Okay? And now, remember I got that expression, absolute value of an expression equal to a number. That's a positive number, so I'm going to split it into two equations. So 3x minus 5, this expression that's inside the absolute value bars, equals 4 units to the right of 0. And then 3x minus 5 equals 4 units to the left of 0. And then you solve each of these equations. So you solve each of these two linear equations. So when I combine like terms, I get 3x equal 9. And so if I get x by itself, divide both sides by 3, I get x to be 3. Okay? Over here, add 5 to both sides, I get 3x equal 1. If I get x by itself, I'm going to go ahead and divide both sides by 3, I get x to be 1/3. All right? Now, so both of those are solutions. Okay? Now, if you want to check, again, you don't have to, but if you want to check, let's check the one with the fraction. So let's just check x equal 1/3. So I'm going to go back to the original. Always go back to the original. Always go back to the original. So here's the original. 2 times the absolute value of 3x minus 5 plus 1 equal 9. Alright, so in place of x, I'm going to substitute 1/3. So I get 2 times 3 times 1/3 minus 5, the absolute value of that expression right here, plus 1, and I want to see if that's going to equal 9. Well, 3 times 1/3, remember that's 1. So I get 2 times the absolute value of 1 minus 5 plus 1 equal 9. That's what I'm looking for. So it's this side right here and this side equal to each other. Well, 1 minus 5 is a negative 4. So I get 2 times the absolute value of negative 4 plus 1. And again, I want to see if that's equal to 9. And remember, the absolute value of negative 4 is 4, positive 4. So 2 times 4 plus 1. And again, I want to see if that's equal to 9. 2 times 4 is 8. 8 plus 1 is equal to 9. Okay, so your two solutions would be 3 and 1/3. So x equal 1/3, comma, 3. All right, and let's do one more. Let's suppose we had, let's say we had this. Let's suppose we had number 4. The absolute value of 6x minus 3 plus 5 is equal to 5. So the absolute value of 6x minus 3 plus 5 is equal to 5. All right, so again, we've got to get the absolute value expression by itself. So I'm going to subtract 5 from both sides. When I combine like terms, notice 5, negative 5, 5, negative 5, those are zeros. I get this. I get the absolute value of 6x minus 3 is equal to 0. So it's 0. It's not a positive number, it is 0. So I want you to think about this. So remember when these were positive numbers, we split into two equations. See if that was a 4? We said this expression inside the absolute value bars must be 4 units to the right of 0 and 4 units to the left of 0. Well, that is 0. Okay, that is 0. So if you did this, if you said this, I just want you to see this, just generalizing from what we just did. If you said 6x minus 3 must equal 0, or 6x minus 3 must equal to the opposite of 0, I want you to know that 0 and negative 0, they're both zeros. They're the same thing. They're both zeros here. And so really all you do when you have this an absolute value expression equal to 0, all you need to do is just solve this equation, 6x minus 3 equals 0. So you're going to end up with one solution in this case. Because remember, you're asking yourself, you want this distance to be 0 units from 0. Well, 0 is 0. So there's only one place, not two like you would here. So 4 units from 0 in the number line. 3x minus 5. Absolute value 3x minus 5, 4 units from 0 in the number line. And then over here, it's negative 4. The absolute value of 3x minus 5 as well. Okay, so so um, um, so 4 units to the right, 4 units to the left. So right in this particular case, though, this is 0. So there's only one spot. Here we had 2 places where that was possible. All right, so then you just add 3 to both sides, and so you get 6x equal 3. And then to get x by itself, divide both sides by 6, and you get x to be 3/6, which is 1/2. All right, and you can check this if you want to check. Just go back to the original problem, which was this. The absolute value of 6x minus 3 plus 5 equal 5. And so wherever you see the variable x, you substitute 1/2. So I get absolute value of 6 times 1/2 minus 3 plus 5. And I want to see if that's going to equal 5. Well, 6 times 1/2 is 3. So the absolute value of 3 minus 3 plus 5. And again, I want to see if that's going to equal 5. Well, 3 minus 3 is 0. And so the absolute value of 0 plus 5, and again, is that equal to 5? Well, the absolute value of 0 is 0. 0 plus 5 is equal to 5. Okay? All right, and let's look at this. So remember we talked about, though, so you got to remember this, though, so you don't make the mistake and forget to check. But if you had this expression, absolute value of 7x plus 2 is equal to negative 6. Right away, you have to remember the absolute value of a number. The absolute value of a number must always be positive, never negative. So there's no way this is ever going to happen. So when you get the absolute value expression by itself and it ends up being a negative number, right away you say no solution. Don't do this. Don't split up into equations, because what's going to happen is you're going to forget to check your solutions and it's not going to work. All right, so you get no solution right off the bat. Okay, so you got to remember this. So this is never negative, or can never be negative. Can never be negative. All right, and then 6. Let's suppose you had, let's say you had negative 2 times the absolute value of x plus 1 is equal to negative 6. And I suppose you had that. Now, you may say, well, you just said there was no solution. I have a negative 6. You just said there's no solution. Yeah, you got to be careful, though. Remember, you got to get the absolute value by itself. Absolute value bar is by itself. In this case, it was. In here, it's not. It is not by itself. So right away, let me go ahead and rewrite this. So remember a while ago when we did this problem, I think it was number 3. When we did number 3, remember the first step was to subtract 1, and then we divided by this number that I'm multiplying the absolute value by. Okay, I divided by that. So what you want to do here is, since I'm multiplying the absolute value expression by negative 2, I want to divide both sides by negative 2. Okay, divide both sides by negative 2. And so negative 2 divided by negative 2 is 1. So 1 times this absolute value of x plus 1 is the absolute value of x plus 1. And negative 6 divided by negative 2 is now a positive 3. And so now you can split it apart. So be careful. Don't confuse this with this. This right here has no solution because you're left with an absolute value expression. Here, you're left with an absolute value expression, but it's being multiplied by negative 2, so you gotta get rid of this coefficient here. Okay, so I get x plus 1 must be 3 units to the right of 0, and x plus 1 must be 3 units to the left of 0. And then you just solve each of these linear equations. So x equals 2, so there's one of your solutions. Over here, subtract 1, you get x to be negative 4. Okay? And you can check this. If you want to check negative 4 mentally, it's easy to check mentally. Remember, always go back to the original problem. Negative 4 plus 1 is negative 3. The absolute value of negative 3 is 3. 3 times negative 2 is negative 6. If you check 2 mentally, 2 plus 1 is 3. Absolute value of 3 is 3. 3 times negative 2 is negative 6. So And what's happening is this. I'm just going to go ahead and do, let's say, this one. So I'm going to just show you what happened in your mind. Okay, you go back to the original. So my original is this. And so in place of x, I'm just going to substitute -4. So you're asking yourself -2 times -4, the absolute value of -4 plus 1. And the question is that equal to -6? Well, -4 plus 1 is -3. So then this becomes -2 times the absolute value of -3. And I want to see if that's equal to -6. Don't make the mistake and say say -2 times -3 is 6. You can't do that. Okay, you cannot do that. That's incorrect. Because -2 times the absolute value of -3 is not 6. So be careful. Mistake is to say this. -2 times the absolute value of -3 is the absolute value of 6. Because what you did was you said -2 times -3, which is absolute value of 6, which is 6, and that's incorrect. You cannot do that. All right, so be careful. So that's why I said earlier, when we first talked about distributing, I think it was in, if I can find it. Anyway, so we talked about the distributive property. I think it was with number 3, if I can find number 3. When I got here, I said you could distribute here. This is positive. That you can do. Since that's positive, it's fine. But if this is negative, you cannot say -2 times -3 and say that's the absolute value of positive 6, which is 6. That's not true. Because what it is this. Absolute value of -3 is 3. -2 times 3 is -6, not 6. And so -6 equals -6, that works. So be careful. Be careful. So just kind of discuss what we just talked about. I want you to remember this. This will be important. So you don't make that error. And if you remember this, remember this. The 2 times the absolute value of -5, let's say. So 2 times the absolute value of 5 is 2, and the absolute value of -5 is 5. So 2 times 5 is 10. Okay, versus. If you want to say, do the same problem. Now, if you want to say this, if you want to say this is, I can write this as the absolute value of 2 times -5, which is the absolute value of -10, which is 10. You can't, so that's true. Okay, nothing wrong with that. Both of these are positive. But let's suppose I had this, -4 times the absolute value of -3. All right, -4 times the absolute value of -3. If I do it correctly using the order of operations, the absolute value of -3 is 3. -4 times 3 is -12. So that's the answer there. But, mistake. If you overgeneralize like you did here, if you overgeneralize using this, you would say this. Let me go ahead and rewrite this over. So the mistake, remember this is a mistake. So the mistake would be to say -4 times a -3. -4 times -3 is 12, and the value of 12 is 12. And notice those are not the same thing. So you can't do that. Okay? All right, so basically, when solving an absolute value equation, you want to make sure you get the absolute value expression by itself. If it is positive, then you're going to split into 2 equations. Just look at this. So you just rewrite the expression that's inside the absolute value bars, and then you're going to say 5 units. In this case, it's 5. So you're going to say 5 units to the right, 5 units to the left. So -5, 5, -5. If it's again, if the absolute value expression is not by itself, you got to get it by itself. If the absolute value expression is equal to 0, notice there's no reason why you could write it into 2 parts, because 0 and -0 are both zeros. You just got to write one equation. So 6x minus 3 must equal 0. And so you get one solution. If when you get the absolute value expression by itself and it's equal to a negative number, right away, you know that can't happen because the absolute value of a number must always be positive. So if it's negative, you would automatically say no solution. Okay, so that's going to take care of part 3, where we were solving absolute value equations.